So today's lesson is probably the most used outside of chemistry. It's over pH. Today's entire lesson revolves around the pH scale, the POH scale, which is a new thing for y'all, and how do we calculate those two things? And what can we use those two things to calculate with other things? You've used pH before in your lives. If you've ever swam in a pool, you know how important it is that your pool water is at a certain pH. If you've ever drank an alkaline water or any pH balancing water, you drink it to change your pH a little bit or to maintain your pH. For those of you that drink Gatorade, sports drinks, etc., that can alter very slightly your pH. You see, pHs of liquids are super duper crucial because they can tell us a lot about what's in the liquid, what's in the solution. Specifically, looking at the concentration of two things. Hydronium, which is that thing we talked about last week when we did Arrhenius acids, as well as hydroxide. That thing we talked about when we looked at bases last week. Your body actually has a natural pH. Does anybody know what the natural pH of human bodies are?
7.
A little more than 7.
7.2.
A little more.
7.5.
It's about 7.35. When you're testing pool water before you take a swim, you test it to make sure that that pH of that pool water is close to the pH of the human body. Why? So that you don't shrivel up and die. Dying, speaking of. Sorry.
No, it's okay.
The thing we're going to do on y'all's lab on Thursday, it's a pH lab. You're going to test the pH of several different solutions and rank them from the most acidic to the most basic. And you're going to use these calculations to help you along your way. So this is a very, very important lesson. The math here can hurt your brains a little bit. So we're actually going to take it into 2 days. First period, we did about 3 examples today. We're going to do 3 tomorrow. We'll see where we get with y'all. Speaking of coming up through the week, tomorrow we will finish out pH and you'll have your homework. We will not see each other Wednesday. Thursday, I will look over your pH homework and we will do the lab. And then Friday is test day over molarity and acids and bases. My aspiration, I think is the word I'm looking for. My hope is to pass out note cards tomorrow. So if you will not be here tomorrow, let me know today and I will give it to you today. Questions, comments, and or concerns? Now, you guys are writing down not only about pH, but also about this thing called the POH scale. The POH scale works very similarly to the pH scale, but only flipped, opposite day. The POH scale is, we're looking at bases. And it really, really focuses on bases, while the pH scale we typically use when we're looking at how acidic something is. It's an easy way to remember, because if you remember, what do all acids start with? What do most bases end with? pH only has an H, mainly looking at with acids. POH ends in OH, typically looking at it with bases. Cool? Can I move on? Draw a beaker with me, please. We're going to fill up my beaker. Do we want to fill it up with an acid or a base? It's an acid. Fill it up with a little hydrochloric acid. my goal by the end of this unit is for me to be able to give you a little bit more of some information, some numbers involved, and for you to tell me a little bit more about that solution. But before we can do that, let's look at the pH scale. See what it actually looks like. I just unfroze you. Do not put it in my face. This is what the pH scale looks like. I'm going to start on this side. So the pH scale, what it really is just measuring how much hydrogen ions or hydronium. That's something that you may want to write down. Hydronium means the exact same as hydrogen ions in terms of what we're going to do today and what you might see on your homework or on test day. But the pH scale is just a measure of how much hydronium or hydrogen ions is in the solution. And it's a little backwards to what your brain might think. The pH scale goes on a scale from 0 to 14. I guess you guys can see this. It goes on a scale from 0 to 14, with 0 actually being the most acidic. If something has a pH of 0, it means there is such an extreme height of concentration of hydronium that one little drop might just take your entire arm off. And it goes down as the pH goes up. So it's kind of like an inverse relationship. This color scale in the middle represents the indicator color. If you remember last week, we talked a little bit about the indicator colors for acids and bases. We said acids typically show up as red. So if I was looking at my most acidic solution, it's a very dark, deep red. And we said bases were typically purplish to bluish. Well, that's down here where the bases are. On the opposite side, you have the pOH scale. The pOH just is the opposite in terms of what it looks like from acids to bases. If something has a pOH of 14, that means it's very acidic. Where if it has a pOH of 0, it's very, very basic. Inversely proportional. So if I were to tell you that a solution had a pH of 3, and I asked you, well, what would its pOH be? What would you tell me? 11. And vice versa. Remind me, what's the range for something being acidic? You wrote it down on the last slide. 0 to 7. What's the range if it's basic on the pH scale? 8 to 14. Good. All right, let's look back to my beaker. So let's say my hydrochloric acid. Just make a hypothesis here, a guess. What would you estimate the pH of hydrochloric acid be? Give me a range. Somewhere between what and what? If it's hydrochloric acid. It's going to be between 0 and 7, right? It's an acid. We know it's going to be somewhere between 0 and 7. Well, let's just say, I'm going to make this up, the pH is actually going to be 2.1. What would its pOH be? Well, if we look, 2.1, that's like 0, 1, 2, like right about there. So if we come over, that's about 12.9 is what the pOH is. Here's the thing. I need us to be a little more specific than that, which is where these different equations come into practice. You wrote these down on the introduction slide. Chemistry is a very, very precise science. I can't just go around guessing, oh, well, it's about this, so we can probably say it's about that. No, that's not how we do things in chemistry. We can look at the concentration of either hydronium or hydroxide to determine pOH or pH. You ready to do a little bit of math?
What?
So you ready to do a little bit of math?
Nope.
Womp womp.
This chips are so spicy. Spicy. times though.
What?
Dude, I need to lock in on my sleep schedule.
There we go. Okay. Numero uno. When we do pH problems, it's really, really important that you pay attention to what you are given and the thing that you're finding. There's a rule of thumb where if the thing you're finding can correlate to the thing that you're given, life is easy. It's a one-step problem. If they don't match, life is still okay. We just have to do extra steps. Let's look here. What's my given if we look at this problem? It says, what is the pH of a 5.5 E negative 3 molar solution of HCl? My given is what? 5.5 E negative 3 molar HCl. Hey, look. HCl, is that an acid or a base? It's an acid. When we're looking for concentrations with pH calculations, we need either concentration of hydronium or concentration of hydroxide. For you guys, you can determine which one it is based off of the compound. In this case, it's hydrochloric acid. Acids always mean the concentration of hydronium. So if you're given a molarity, a concentration of an acid, that's your concentration of hydronium. If it was a base, then we would use OH minus. Cool?
Cool.
What am I solving for?
pH.
We're solving for pH. Hey, think for a moment. pH and hydronium, are those two things directly related or not related? Look, pH, imagine that was hydronium. Are they together or not together? They're together, which means life is easy. It means we only need to do one of these 5 equations up here.
Just because they're together doesn't mean life is easy.
We have hydronium. We're looking for pH. Hey, looking at my 5 equations here, which one do you think we're going to use to solve for pH here? The top one. Look, the top one, it's the only one that has the thing we're looking for and the thing we're given. I'm going to label that as equation 1, unless that hurts anybody's brain. So equation 1 says pH equals negative log of hydronium ion. Plug and chug, just like always. We do negative log of 5.5 E negative 3. Hey, these fancy parentheses, those are called brackets. Brackets just mean concentration, so don't let that hurt your brain. Somebody type that in your calculator, tell me what you get. If you do not know how to use the log button on your calculator, let me know and I will teach you.
What is log?
What's a log? It's a math function.
Is that like an algebra thing?
I think you use it in algebra 2.
Yeah,
Yeah.
Yeah, but I'm not in that class yet. Yeah, I don't think I can do this.
Get your calculator out.
I think this is out of my paper.
Get your calculator out and I'll show you how to do it.
Stop yelling.
We're just sitting on applesauce. Hurry up. Okay, so we're going to do the negative, and then log is just this button here. So you're going to do negative log, and then you punch your 5.5 times 10 to the negative.
Oh. That was easy.
What do we get when we type it in? What?
2.6. Is there 6
Is that
in here?
exponent?
Yeah, we'll do 3 sig figs.
3.26.
80 got 2.26 for pH. Is that what everybody else got when you round to 3 sig figs? I agree. Hey, here's the thing though. Sometimes when you get these numbers, for whatever reason, your brain says that doesn't look right. There's an easy, super duper easy way to determine whether or not you're at least in the right range. Hey, we had hydrochloric acid here, right?
Something like that.
Well, just look. We have hydrochloric acid. Hey, there's a super duper easy way to determine if you're in the right range. You see how we were times 10 to the negative third here?
Yeah.
That means on my pH scale, if you go to 10 to the negative third, we should be somewhere in between 2 and 3.
Dude, are you serious?
So that's a super duper easy way to check your work. Cool.
Oh my goodness.
All right, let's do another one.
Those reels were a mistake.
Here's number 2.
I'm sorry.
Number 2 says, what is the pH of a 9.4 times 10 to the negative fifth molar solution of sodium hydroxide? What's my given gauge?
9.4 e to the negative 5.
E negative 5 what?
Always.
Molar. Molar of what? Do we have a concentration of hydronium or a concentration of hydroxide? Hydroxide. Because look at the compound it's talking about. It's talking about sodium hydroxide. It's in the name. So we have concentration of hydroxide. What am I solving for here? We're looking for pH. Hey, but look, we have pH, but we're given the concentration of OH minus. Do those two things go together?
No.
No, that means life is a little harder because I have to do an extra step, essentially a conversion step. Well, let's think. I'm given OH minus. Is there something that I can turn OH minus into that might help me get to pH?
Hydronium.
We could turn it into hydronium, but you guys are not learning how to do that. That's next year for you. You said this guy?
Yeah.
Okay, we could use that route. So we can solve for the negative POH using that.
It sounds like
Yes, but I would say that one's probably a little harder. There's an easier way.
Yo, I say we do H3O plus equals 10 negative pH.
Can't do that one. We're actually going to use this guy. We're going to use equation 2 because look what happens. I can plug this directly into equation 2 and get POH, and then I can just use equation 5 to get to pH.
Yo, what?
Watch what I do. So we're going to use equation 2 here, and we're going to do POH equals the negative log of the concentration of OH minus. I'm going to plug in 9.4 E negative 5 in my log. When you plug that in your calculator, what do we get?
I don't know.
So plug it in and find out.
Writing it down.
What'd you say? 4.03. We get a POH of 4.03. I need to find pH. Looking at my list, looking at my list, looking at my list. Oh, here we go. I have pH and POH in the same equation. Equation 5. says that I can use 14 equals pH plus POH, and I can plug and chug. For 14 equals pH plus 4.3, subtract 4.3 from both sides. Did anybody else get 9.97 for your pH?
Yes. But how do you know like which equation to use?
I think at the beginning, it's going to be trial and error for you. So you were trying to do, somebody said this guy, can we use this guy? You can use this guy, but you need to know how do you get rid of an exponent on a 10? That's hard. Too much math for you. Hurts my brain. So then you just look for a different
So why is
equation.
he here?
Huh?
Why is he here if we can't use
We're going to use them eventually.
Bruh. And this or for like
No, we're going to use it in like 2 problems.
bruh. Oh. I'm bruh, no.
He's coming. But
It's too hard for you, but we're gonna use it in 2 problems.
no, it's hard for you to get rid of the exponent part. We're not going to have to get rid of the exponent part when we use it. To get rid of the exponent part, you have to do like natural logs and things, which is annoying. Hey, try this one on your own and see what you get.
Oh, bruh.
Is it doesn't the one where I have to
Oh, it's
No.
Why is it flying gravity? Oh.
Yeah, you don't want to do math.
Why is my belt not in my belt, bro?
All right,
Wait, that
so looking at this guy,
and then you had to like put it on the chart what you wanted.
Yeah. Yep, I'm not.
Or was that a different thing? Oh no.
it looks like I have a given. Who agrees with me? My given is 2.6
What'd you do yourself?
E negative 7 molar. Do we have hydronium or hydroxide here?
Hydronium.
Hydronium, because we have an acid. What am I solving for, though? We're solving for POH. Are they directly related or not?
No.
That means life is hard. We have to do 2 steps.
Wait, so the ones that are directly related is the
pH and hydronium, and POH and hydroxide. If it's not one of those 2 combinations, it means you have to do 2 steps. I can turn H3O plus into something. What can I turn H3O plus into? I can turn it into pH. Which equation can I use for that? The very first guy. I can use equation 1. What then can I do once I get my pH? I can use equation 5 to get to POH. Let's do it.
Oh, it's so cold in here.
So equation 1, we use pH equals the negative log of hydronium.
Sorry.
Plug and chug, we'll get pH equals the negative log, if I can write properly, of 2.6 E negative 7. Plug that in your calculator, what did we get? 6.59.
What do you know about country snail?
Stop. I'm not done. I'm given a pH. I need to get to POH. We said we can use equation 5 for that.
I just get trauma from country snail.
Equation 5 says 14 equals pH plus POH. Plug and chug. 14 equals 6.59 plus POH. Subtract 6.59 from both sides. Did anybody else get 7.41 for their POH? Yeah. You got that? Good job. Hey, has anybody noticed how POH and pH are unitless? Easy points. There's no units for pH and POH.
Wonderful.
So keep that in mind.
I can keep points there.
I'm feeling lucky. I'm gonna spin the wheel for number 4.
What are you talking about?
We're spinning the wheel.
Spin
Oh,
the wheel.
What wheel?
The wheel of your names. See who's gonna come do it on the board.
No.
I can figure it out if I really have to.
This is your opportunity.
Dude, I really don't
I don't know
know.
about
Casey, how much time do you think you need?
I don't know. 3 minutes.
3 minutes? Okay.
Regan? Is your name Casey?
Last time I checked, Reagan, it's
See you in 3 minutes.
Bro, I can't believe this is
All right, there's number 4. Good job, KJ. All right.
I'll just ask her
Let's
for
do-
another day.
Another one.
The chance that we're no, because Haley's asking.
Yeah, these are only 3.
Yeah, well, you gotta be going a lot faster before first period. So.
Let's just ask her all.
All right.
Okay, turn this off. Turn this off.
I'm gonna do this one with you.
I don't want to play this game anymore. I'm tired of playing these games, Mr. Mead.
So is that a yes when we talk to set up the lab?
When you said toxic, I just nodded my head in green.
Yeah, we'll be
Number 5.
I'll be in here.
What is the concentration of HBr? What's the name of that acid? We should be really good at naming acids now. Hydrobromic acid in a solution with a pH of 2.11. What's my given here?
2.11
What is my 2.11?
pH of HBr solution.
So we have a pH of
Oh, that was just
2.11. What am I solving for?
Concentration of HBr in a solution.
I need concentration. Now, it didn't necessarily tell me what concentration I use, so we're going to say concentration of H3O+. On your homework and on your test, I will tell you which one to solve for. So, hey, I need an equation. What equation can I use that involves pH in hydronium, but I need to solve for hydronium this time?
Yo, it's right there.
Middle one.
The third one. It's the third one.
Number 3. Let's try it out. Equation 3. We have hydronium equals 10 to the negative pH. Don't overcomplicate it. Plug and chug for pH. Hydronium equals 10 to the negative 2.11. Hey, plug that in your calculator. Tell me what you get. 10 to the negative 2.11. You should get a fairly small number here. It's easier to put your calculator in scientific notation if it helps. If you have a TI calculator, I can help you do that. If you don't have one, sorry, I don't know how to do it on this.
Scientific. Bro, you just put alpha. You put shit. Alpha.
Sure.
I don't know actually.
What are we getting? Tell me in scientific notation. I don't do long decimals.
7.76 to the negative third power.
Ethan says 7.76 E negative 3. Does anybody else agree?
Sure.
Good job.
You better figure out how to get my stuff.
I don't know. Just good job.
I kind of forgot.
I agree.
I have no idea how he got that.
You have no idea how I got this?
I don't know how he got this.
These
That's just times 10 to the blank. So how many times do you have to move the decimal? Okay, if you did it, if scientific notation is hurting your brain and you write this,
Always.
and if you write that, you're right. Like, I'm not going to count you wrong. It's just
Oh, it's
you're writing a lot more. You're literally just moving the decimal. It's scientific notation.
So it's in between 0 and 10, or 1 and 10, or whatever. That's the rule of scientific notation. Yes.
Yes.
I suck at science.
It just that was like the easiest thing we ever did. You guys were genuinely help.
Okay.
Like within reason. Like I don't have to
All right. We got one more, and then we're going to be good to go.
Bruh.
Bruh.
Bro, we have 2 minutes. Just get me out of here.
I almost smacked you. I refrained myself from
We have
smacking
6 minutes. Do not play in my face.
Oh,
Dude, I might be getting played in my face.
it's just gonna be like that.
Amy, you want to come do this one on the board?
Sure.
No way. You're kidding.
Okay. I'm telling you, I could have.
I don't know what time we're gonna try to go play.
Yes.
Natalie, what's my
'Cause
given?
I don't know who can drive. I know I can't.
7.87.
I know yet. I'm gonna see some kids from Greenwood. Can you-
7.87. What is that?
POH.
POH.
Why are you laughing at me? I'm right.
The Raymond Senior.
What am I solving for? We're going to say it's the concentration of H3O plus again because we're talking about an acid. I'm given POH. I need to find H3O plus. Are they correlated or not correlated?
They're not.
Not correlated. We have to do extra steps. It's okay.
Of course.
So, what can I turn POH into that might help my getting to H3O plus?
OH.
Huh?
Never mind.
I could turn this into concentration of OH, but that wouldn't help me here. We could use number 4. We could use it, but we don't know the other piece of
I
the
say
puzzle
we
to
use
get.
number 3.
Okay.
Bro, just. Wait, just do this.
Hey, what can I use to get to H3O plus? Let's go backwards. I can use what to get to H3O plus?
Number 3.
I could use number 3. I would need pH. I can use a pH to get to H3O plus. We agree?
Yes.
What can I get? Can I get from POH to pH? Number 5. Use number 5 first. When we do number 5, we'll get 14 equals pH plus POH. Plug and chug, 14 equals pH plus 7.87. Subtract 7.87 from both sides. I get 6.13 equals pH. Does anybody agree? Now I have pH. I need to find hydronium. What equation will I use? 3. We'll use 3 here.
Friggin' hop off, bro.
H3O plus
I thought she said Raymond.
equals
That's a small number.
10 to the pH. H3O plus will equal 10 to the negative 6.13. Plug that in your calculator. What do you get?
613. That's my birthday.
7.41
Yo, what?
You're both
I'll be
telling me bad
17.
numbers. 7.41 E negative
I'm
6.
done being cougar.
Ethan got 7.41 E negative 7
I'm done growling. I'm going
for the concentration of hydronium. Did anybody else get that?
Yes, I got that.
Now, remember, molarity, concentrations still have a unit. Make sure you put a molar for concentration. Minus half point. All right, you'll have all day tomorrow to work on your homework in class, so I'm ready to work.